It works. All right. Good afternoon, everybody. Welcome to another fun-filled afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. All right, let me fill you in what we're going to be doing today. First of all, I'll be going through the carboxylic acid and ester problem set. And don't forget, there's no such thing as a dumb question in my class or in my world. Then I'm going to do some more lecturing on amines, and then we'll do the carboxylic acid lab. And with that, before I get going, any of you have any questions for me? Well, in that case, I better get going. All right, everybody see the carboxylic acids and esters problem set. All right, thank you, Megan. On test number 3, there'll be nomenclature questions, just like 2 and 1. And there are 2 types. One is give the IUPAC name for the following, and the other you'll see draw the structure from the name. All right, now we look here, carboxylic acid. How do you name that? Find the longest chain, 4 carbons with the carbonyl carbon, carbon double bond oxygen, name that as an alkane, butane, drop the E, add OIC in the word acid. Now, when R is a benzene ring in a carboxylic acid, the common name has become the IUPAC name, benzoic acid. Now, when you have an alkyl group or substituent on the R group, the carbonyl carbon is always number 1 because carbonyl carbon is rock. That's why I'm a carbonyl carbon organic chemist. But anyways, 5 carbons, notice carbonyl hydroxy group carbon, and we have pentane, drop the E, add OIC, the word acid, pentanoic acid, and then in front, methyl group, and it's on carbon 4. So it's 4-methyl pentanoic acid. And if we make it more complex, here's example E. Now, when you have a carboxylate anion, you name it. First of all, there's 2 methods. One is when R has this carbon's no benzene ring, you name it as the longest chain, drop the E, add OATE, and the cation, that's the plus charge element next to the oxygen minus of the carboxylate anion, is named as the element it came from. Now, when R is not this carbons like a benzene ring, you have to use the original IUPAC method, which is name the carboxylic acid that this comes from. And if this were an H instead of O minus K plus, that would be benzoic acid. And you drop the IC in the word acid and add ATE, benzoate, but the front, you still name it as the element it comes from. Now, here we have an ester. And remember, ester R, carbonyl O, R prime. And how do you name that? Well, you can use the 2 methods. If R attached to the carbonyls is carbons, like this example, find the longest chain, propane, drop the E, add OATE. Then the carbons on the oxygen here, you name as R prime, in front as the alkyl group it comes from. And hi, Tam, we're getting going on things. But anyways, I'm going through the carboxylic acid and ester problem set right now. All right, so this is an ethyl, and this would be ethyl propanoate. Now, when R is not carbons, you have to use the IUPAC method. Pretend the methyl group here is a hydrogen, so this carboxylic acid would be benzoic acid. You drop the IC into the word acid, add ATE, you get benzoate. And since it's an ester, you have the R prime, the group on oxygen here, you name as an alkyl group in front. Oh, excuse me. And that's methyl benzoate. Now, my gift to you, don't tell anybody I'm being nice, please, is I will not, for esters or carboxylate anions, put alkyl groups on there, because between the isopropyl here and the octanoate, you'd put the substituents with numbers, and it can get very complex. And for this class, it's not really necessary. So I'm giving you a gift. Now, the other type of nomenclature question for test 3 will be, and also when I say test 3, what I really mean is nomenclature skill you should have from learning organic chemistry is draw the condensed structure for the following organic molecules. And here I'll have common names, and acetic acid is the common name for the carboxylic acid you see there, where R is a methyl group, and it's a carboxylic acid. Now, if we look at C, and by the way, this is a very, 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 I don't think I mentioned it, very nasty molecule. It gave me about 8 weeks of grief, and I'll explain that later. But 2-ethyl hexanoic acid, you start from the right, move left. OIC acid, carboxylic acid. If that was an E, hexane, 6 carbons, the carbonyl carbon is number 1, carbon double bond oxygen, hydroxyl group, and carbon 2, we have an ethyl group. And same thing for D. And here I give you some more E, a little more complex, but it's the same thing. Now, let's look at F. You start from the right, move left. OAT ending can either be an ester or a carboxylate anion. You look in the front, and if you see an element name, it's a carboxylate anion. If you see an alkyl name like ethyl, then it's an ester. And so if it's an ester, if this were an E, propane, 3 carbons, carbonyl, oxygen, here's our prime, ethyl. Now, I made a mistake on G, just cross that off, because I said I wouldn't put anything on the alkyl, and oops, I made a mistake. Now, there's one common ester name you should know, just like carboxylic acid, you should know acetic acid. Ooh, time out for a special thing, a public service from me, Dr. White. Remember, when you leave my lecture like now, you can still think about organic chemistry, because organic chemistry is everywhere, all around you. Anybody happen to pick up a bottle of vinegar and see or know that vinegar is water and acetic acid, which is a carboxylic acid? Now, the other one I'm about to do is ethyl acetate. And ethyl acetate is found in where? Nail polish remover. It's one of the 2 types. The other you learned before, acetone. And for many years, ethyl acetate was the main one. If you went into any big box store, you'd see. But once they had the super durable nail polish, you know, the ones where you put your nails under the light. I don't have a UV light. And those are really tough, I've been told, really durable nail polish on you. The way to get that off, acetone works better now than ethyl acetate. But you shouldn't think about those things. All right, so ethyl acetate is the common name for the molecule that nobody ever uses the IUPAC name of ethyl ethanoate, acetic acid, and then instead of an acid, the ATE ending tells you it's an ester and the R prime is ethyl. Now here, if we look at I, we have sodium benzoate, OAT, E can be either ester or carboxylate anion. The sodium in front tells you it's a carboxylate anion. And since this doesn't follow, you can't use the to be or not to be. That's a question I can't resist that my student a long time ago came up with. You have to use the IUPAC. This benzoate comes from benzoic acid, except the H is replaced with a O minus and a sodium plus. Now, I made a mistake, cross off J. I'm not going to do magnesium or calcium on a test in this class ever, okay? Now, on test 3, like test 2, the majority of the points, I think 65 out of 105, there'll be 5 bonus points. I got to write it this weekend. Will be, excuse me, I got something in my throat. Draw the condensed structure for organic product or products for the following reaction, and there'll be either 3 or 4 synthesis problems give the starting material. And here, now you have to look at what's different, what's not carbon, what's not hydrogen, what's not a carbon single bond, carbonyl hydrogen, carbons, aldehyde. Oxidize it, carboxylic acid, the H becomes an OH. You don't break carbon-carbon single bonds. And I give you more complex aldehydes. By the way, D is the chemistry instructor's favorite trick on the test. That is, put a big, scary molecule. And if you haven't looked at molecules where you look for the functional group, you get scared and do the wrong thing. But if I've done my job right, and you've done yours, look for what's different, carbonyl with the hydrogen carbons, aldehyde. This all stays the same. The only change is H becomes OH. Now, hold on one second. Guess what? I forgot a reaction on here. Bad, Dr. White. So I'm going to fix that right now. If you take a primary alcohol, and strongly oxidize it, you'll get a carboxylic acid. So I'm going to let you try a few. What would be the organic product or product for the following reaction? 3 points each. And don't forget when you're done, oh, you remember, give me the thumbs up. All right, I better get to work. If we look what's different, ooh, oxygen with a hydroxy group on a carbon with carbons here, we're oxidizing it. So it's important to realize this is a primary alcohol. And when we oxidize it, the carbon with the hydroxyl group becomes a carbonyl carbon of the carboxylic acid. So what's R here? These 2 carbons. This carbon is this carbon. And now becomes this carbon. Now, notice you start with 3 carbons. You better end up with 3 carbons because this does not break carbon-carbon single bonds in this reaction. And that's always a good tip to remember. Do you break carbon-carbon single bonds? No. Oh, let's do one more. Let's do a synthesis. And the question would be, what's the starting material that you oxidize to make that molecule? Thank you, Megan. Thank you, Joe. Thank you, Tam. Sorry, I got to make you do that. If we were in a classroom and everybody, I could see everybody, I could see your faces and look and say, oh, everybody's done, but we're not. So that's why I came up with my thumbs up. All right, we look at here, what's different? What's not a carbon-carbon single bond or carbon or hydrogen? Ooh, oxygen's here, here, and we have a carboxylic acid. And what do we oxidize to make a carboxylic acid? Well, in this case, there are 2 answers. Since I have here the alcohol, you could have also put the aldehyde. And if I were to put this on a test, both would be correct for this class. Either one of these from the previous reaction, but let's stick with this reaction right here. Here's my R group, not counting that carbon. Hold on. Let's try that again. That's better. That's my R group. So this carbon here, carbonyl, becomes this one of the primary alcohol. And that's how you do it. And let's get back to our problem set. Now, a really cool way, literally and figuratively, to make a carboxylic acid is to react a Grignard. Remember, look for what's different. Ooh, MgX, halogen. I didn't have it here, but X can be chlorine, bromine, or iodide. And a Grignard, and you make a carboxylic acid that's 1 carbon longer than the Grignard R you started with. And here, 2 carbons, 3 carbons. And here, I put this one down because it's interesting. I don't know how to make this compound any other way than using a Grignard reagent with carbon dioxide. And this will be R is the benzene, not benzene, cyclohexane ring, and my carbonyl and hydroxyl. And I did the chemistry instructor's favorite trick on a test, and that is put a big, scary R group. But if you don't get scared by that, it's simple. I have a Grignard, carbon dioxide. I have, this is my R group, and I add C double bond O, OH. Now, carboxylic acids are acids. Sodium hydroxide is a base, and you pull off the proton and make this carboxylate anion, where the cation comes from the base sodium. Also, here's the general reaction. You can have other for this class. M can be lithium, sodium, or potassium. And in C, guess what? It's potassium. So I pull off that hydrogen, proton really, and get this carboxylate anion. Remember, all molecules in nature in chemistry have a net 0 charge O minus K plus 0. Now, let's look at number 5. This is different. Draw the condensed structure for all of the products for this reaction. And the reaction is reacting a carboxylic acid, that's what this is, with baking powder to form the carboxylate anion. You give CO2, the arrow pointing up tells you that CO2 is a gas, carbon dioxide. Those are like the bubbles in pop, which are also a gas, and water. So if I have this, what's our methyl? Get sodium acetate, which I didn't teach you how to name the common name. But anyways, then water and CO2 given off as a gas. And remember, this is the reaction for the rocket ship I showed you. Remember the little candy filled rocket ship with the most awful, terrible candy. How do you know that? Well, you give that to a 5-year-old like me, and you take it, open it up, and you take the candy and you dump it in a little garbage can. Because what 5-year-old would dump out candy? Candy that's disgusting. But the rocket ship was fun to play with. And if we look at B, all I've done is very more complex. R group, same thing, carboxylate anion, water, CO2 given off as gas. All right, now 6A, cross off. I got, let me put down a different base, and I shouldn't have done that. Same thing with B. All right, let's go to C. What do we have? Remember, it's important for you to identify functional groups and molecules that are now reacting together. And here, look for, again, what's different, what's not carbon, what's not hydrogen. Ooh, 2 oxygens and a hydrogen here, carbons here, carboxylic acid. Carbon hydroxyl group, alcohol. Acid catalyst, remember H plus is acid catalyst that can be usually sulfuric acid. There are other organic acids that I don't teach in this class, like methane sulfonic acid and para-toluene sulfonic acid. But H plus, and you make an ester. The R group is not affected, and the hydroxyl group is replaced by R prime. The carbon in R prime with the hydroxyl group is the carbon bonded to R prime in the ester. So if we look at D, we have a benzene ring, but that's not going to react with an alcohol and acid. That's this, R group. Carboxylic acid, carbon hydroxyl group, alcohol. And notice you get an ester, R, benzene ring, carbonyl, oxygen. Now notice the hydroxyl group on R prime is to the center carbon. Therefore, the oxygen, the ester, will be to the center carbon of R prime. I'll say it again. The hydroxyl group in R prime is to the center carbon, and therefore, in the ester, R prime will be bonded to that same carbon as oxygen, and it is. If you notice in E, I have my R prime 4 carbons, which carbon has the hydroxyl group, the end one, which is why is this ester. Now, if we take an ester, you can react it with base, and I forgot to put the water down, bad Dr. White. I won't on the test forget that. But anyways, with base and water, that's called saponification of an ester, and you get back the carboxylate anion, not the carboxylic acid, the carboxylate anion of the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. Carbonyl, oxygen, carbons here, ester. This is my R, this is my R prime. I get this carboxylate anion and this ester. Now the carbon with the oxygen in R prime will be the carbon with the hydroxyl group in this alcohol. Now let's see if I have this one here. No, wrong thing. And here I just have this one. Oh, you know what I'm going to do? I'm going to let you have some fun too. And why don't you try this one? What would be the product or products? I'm going to help you out in a test. I do this, which would tell you, or I might even do this. But if you just see the plus sign, that tells you there are two things. Thank you, Joe. I might have missed Megan's. I think everybody's done. Thank you. All right. First of all, what's different? Ooh, oxygen here, and we have a carbonyl. Oxygen, carbons on this oxygen, I'll call R prime, carbons on the carbonyl, I'll call R, it's an ester. And if I react it with base, and for this class, I think for this reaction, I just kept it to sodium hydroxide. You'll get back not the carboxylic acid, but the carboxylate anion of the carboxylic acid you would have used to make that ester plus the alcohol. So if we look here, this is R prime. So I'll have this ester, acetic acid, this ester, this carboxylic acid, plus notice the oxygens on this carbon of the R prime, meaning the hydroxyl group will be on that carbon too. And we don't break carbon-carbon single bonds, which we haven't. Carbon-oxygen bonds, you can break those all the time. They're easy. Now, if you had taken ester and reacted with acid and water, this is acid hydrolysis of an ester, and you'll learn later this semester, this general reaction is how your body breaks down fats and oils. But you didn't know you were a walking chemical organic chemistry plant. You are. Well, anyways, ester, acid, and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. Remember, the carbon with the oxygen will be the carbon with the hydrox group in R prime. So if I have here, here's my R group. Therefore, this is my carboxylic acid. Here's my R prime. Here's my alcohol. And all I did was put some big scary R groups there for you to practice with. And finally, my favorite, and I have to apologize, organic chemists usually don't balance it. For this class, when I started teaching this, students had trouble, so I started putting the 2 there. If you were at my level, you don't put the 2 there. We're that lazy. Well, let's look at this one. We have a ester reacting with 2 molecules of a Grignard, second step acid and water. And this is one of those special reactions where you can make not one, but 2 very special carbon-carbon single bonds, something so important, so rare, so wonderful. And I've done this reaction, it's fun. And here you get two products. Here's my ester, what's attached to carbonyl carbon. And let me write it on the other screen because I want to do something I don't have on there. I could have put this right here on top of the RO2 like you see me do. I just didn't feel like it. Both are the same. Remember, X here is chlorine, bromine, or iodine. My other class, which is at the other school, most of the students can't read cursive, so I got to print everything. All right, keep your eye on the carbonyl carbon. What's attached to it will still be attached to it. This will become an alcohol. And now you're going to form not one, but two bonds to that carbon from the Grignard. And also, this right here will become a second alcohol. But the key you're trying to make is that, but you'll also make that. So in the real world, you try and keep R prime as small as possible so you can distill it off easily to get the complex alcohol. And if we look here, we have R is a benzene ring, R prime is methyl, R triple prime is methyl. I make this alcohol here, and this alcohol comes from R prime. Remember, for this reaction, I will never put on a test a synthesis problem because that's cruel and unusual punishment towards students. And I think that's still outlawed by the Supreme Court of the United States. If you notice, I had fun in E. I have a very complex or simple ester, a little slightly complex Grignard, and look at the alcohol you made here, and you keep R prime small, and this is the other alcohol. And I give you one more here also. Any questions on esters or carboxylic acids? Remember, when you're through my class today, if you happen to be home or next time you're in a supermarket, in case you don't have any, go over and pick up a bottle of vinegar and say, ooh, it's got a, you don't have to do the ooh part, but you can say, oh, I know it has acetic acid, which is a carboxylic acid. Or you could pick up a container of ketchup, mustard, or a jar of pickles, and they'll all contain vinegar, which vinegar contains acetic acid, which is a carboxylic acid. All right, any questions on that? All right, let's go back to amines and their derivatives. And I was talking last time we met, Monday, about amine salts. And I gave you the general reaction, the following, which is better than what I have on the slide. Dr. White's a lazy organic chemist, so I didn't change it. If we have this molecule, R prime and R double prime, one or both, or none can be hydrogen. So that covers primary, secondary, and tertiary amines. How do you know it's an amine? 3 bonds to carbon. What am I saying? 3 bonds to nitrogen. I do that every semester, at least once, maybe even twice. And then if we add an acid, and I'm going to stick to these hydrogen halogen acids, you'll form an amine salt. And I talked about the nomenclature already. They're the same as quaternary ammonium salts, identical, except in a quaternary ammonium salt, the name will have 4 R groups. In an amine salt, it will have 3 or less, 1, 2, or 3 R groups, never 4, because then you'd have a quaternary ammonium salt. Ooh, that reminds me. Did anybody happen to look at a dryer sheets or the bottle of fabric softener, the dryer fabric softener, and think that's got a quaternary ammonium salt in? Remember, that's near and dear to my heart. Did any of you happen to pick up mouthwash and see it's got a quaternary ammonium salt, which keeps Dr. White's gums nice and healthy? Before, if I hadn't been using that, I'd be in serious pain right now. I'm not. Thank goodness. Think about it. Organic chemistry is all around you. I'm not going to give up till the last day of the semester. Do you realize this is the end of week 10? Boy, our time's gone zoom. Hope you're having fun. I am. By the way, do you notice I've got my sweater on? Because in my house, and especially when it's not cold enough outside to kick in my furnace a lot, I don't keep my furnace that high. I'd rather put on a sweater. But anyways, this is one of my old favorite sweaters, which I like a lot, obviously, because I still have it. All right, so let's do 1 or 2 of these. And what would be the organic product or products for the following? Thank you, Tam. From 2 of you with windows behind you, does it look like the sun's trying to peek out where you are? Yay. All right, let's do this. What's different? Ooh, nitrogen with carbons and carbons. It's an amine, which I could draw like this. And remind myself, is everybody familiar with the ampersand meaning and? No, you are. R prime and R double prime can be hydrogen. In this case, one of them is. So I can call this, it doesn't matter what you call what. And when we react it with an acid, where X can be chlorine, bromine, or iodine, you get getting ahead of myself. And you don't have to put the charges there, but I will. Good habits I don't break. So I have on nitrogen, my methyl, my ethyl, and my hydrogen, and I'll add one more. Don't forget the anion, which comes from HCl, in this case chlorine. Now, we put it to the right, but I could put it here, 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 because that's really bonded to the nitrogen, what we call an ionic bond. When I say 4 or 3 bonds to carbon, to nitrogen, it is talking about covalent bonds. Oh, let's do another one. And there's one more for you to have fun with. And don't forget, if you have any questions, I have my office hour tonight. Thank you, everybody. I see you're all done from 5 to 6:15. Well, if I look here, what's, a nitrogen with hydrogens and a carbon. That's a primary amine. But for this reaction, we have HX, an acid. Where R prime and R double prime, one or both or none, can be hydrogens plus HX, remember X equals chlorine, bromine, or in our case, iodine. And this is an acid-base proton transfer. And here, I'm going to call this R. And these two hydrogens are R prime and R double prime. And obviously iodine, well, maybe not obvious, but it's X. So I'm going to have my R group on the nitrogen. I have these two hydrogens, R prime and R double prime, and I'll add one more. And then I need my anion, and you don't have to show charges, but I will. Now, one thing I should point out, notice this nitrogen has 3 hydrogens on it. So I could have written it like this. And this is something you should be familiar with, which is why I'm showing it to you. Which structure is correct on the test? Both would be. And that's how you do it. But before we leave amine salts, there's something I need to do. How many of you remember I've been asking more and more of you that you should ask the question, why am I learning this stuff? Well, the obvious answer is you want to get a good grade because someone said you had to take this course to get into a program or a school to get into that school's program. So you want to get a good grade. But why should you learn this stuff, really? Well, amine salts are what we call ionic, or more importantly, polar compounds. And when you make something polar, you help make it more water soluble. And if you have any over-the-counter drugs, and some also prescription, but a lot you can see easily in over-the-counter, you'll see, and they use a pharmacy common name or pharmaceutical, and that is, you'll see a name and a dot and like HCl, or you'll see a name and then you'll see the words hydrochloric acid or hydrochloric, and or mostly hydrochloric. Why is that? Because in the medicine you're taking, they had a nitrogen amine in there, amine, and they react with acid, make it polar, so it's more soluble in your stomach, but more importantly, more soluble in your blood. Everybody see my blood vessels there? Yeah, well, that's a better one. Anyways, that happens. Now, Mother Nature does the same thing. I'll teach you later on. Amino acids have a primary amine. And when you consume it in your stomach, remember down here, we all have, and this I always think of as one of the great miracles of life, we have cells in our body that synthesize, make hydrochloric acid, because your stomach is acidic, and I'll show you how it helps break down the food. But when you eat something with protein, you break it down to amino acids, and the amine there gets reacted with the acid in your stomach to make an amine salt or amine salt carboxylic acid, and that makes it more water soluble, which means it's easier for your blood to transport it to the parts of your body that need amino acids. Now I'm well beyond my knowledge of the human body. Did I tell you last time I took biology was freshman year of high school? Nothing wrong with biology, but by then I knew I wanted to be a chemist. All right. Oh no, guess what time it is? It's time for a new functional group. Let me, first of all, here we were. Guess what new time it is? Instant replay. It's new functional group time. And that new functional group is called an amide. And an amide is a carboxylic acid derivative, meaning it's derived from a carboxylic acid in which the OH of a carboxylic acid is replaced with N and R prime and R double prime right here. This is an amide. And remember, in this case, just like I've said before, in amines, R prime and R double prime can be hydrogen. Now, if you notice in an amide, it's like an amine, it has 3 bonds to nitrogen. So amide nitrogens always have 3 bonds. So nitrogen has 3 bonds to it unless it's a quaternary ammonium salt or an amine salt, then it has 4 bonds. That always gives students trouble, but you've just got to remember it. Now, skip this slide. I used to talk about this. I'm not going to. Switches off, but in case in other classes you hear something called lactam, that's just a cyclic amide. Again, switches click off for the slide. But in case you hear about it and others. Now, a very interesting amide, which at first glance you say, is that an amide? Well, this reacts like amides, so it's considered an amide. That's where R prime and R double prime are hydrogens, and the R group is not carbons, it's NH2. And another way of drawing this so you can see it better. And this is called urea. And urea is the major organic chemical in urine. It's our body's way, one of them, a key way of getting rid of nitrogen waste. Now, urea is a white solid at room temperature in your urine. It's obviously in solution, dissolved into water in your urine, but it's also used to make certain polymers, which I'll talk about. Uh-oh, I've gone over. It's time for our break. Today to catch up, we're going to go a little longer than normal, but I'll still get you out before midnight, long before midnight. Let's take a 5-minute break. What's the clock say? Come back at 1:56. I can get up and stretch. Time to get going. Sorry about the minute late. I realized I needed a refill. I had to go all the way down to my kitchen to get one. Oh, don't you feel sorry for me? You shouldn't. Anyways, let's continue with amides. Now, I was talking about urea, and urea is also an important chemical used in the chemical industry. And it's used to make what's called urea formaldehyde polymers. And this is a very important end use of urea that chemists now make synthetically. They don't get isolated from urine. No, they don't. And one of my more unpleasant memories was at a chemical plant I worked at where I was supervising with the chief engineer, a new reaction using urea. We had these super sacks that are filled with about 2,000 pounds of urea as a powder. Well, we opened it up and it was rock solid. And I and 10 other workers, or maybe not 10, about 6 or 7, plus myself, spent the next hour or so with heavy sledgehammers breaking it up. I got a good workout that morning. But anyways, let's continue. Now, an important amide is called the common name capsaicin. How many of you are familiar with peppers? You know, you can get certain types of peppers like jalapeno, and they've got a kick to it. And if you really want to live dangerously, you can get habanero peppers, and those have a dangerous kick to it. Well, what's the difference between the two? The amount of capsaicin right here. And this is an amide. And here is my one R prime is this right here, and the other is this hydrogen, and this is my R group. And not R prime, R group. And that's capsaicin. Now, I'll teach you more about something later on, but I think it's time, yeah, I've got time to tell you about one of the dumbest things I've ever done in my life. Boy, was it dumb. Place, and let me, first of all, do this. One of the best places I know of in the United States, and one of their stores is located in Evanston. I might have mentioned this, I think I did. Why did I? This is the Spice House. And like I said, they're both in Chicago and Evanston. They used to have a store out in, I forgot what north, sort of west of Elgin, but they sold that. But anyways, and they now have ghost peppers. Whoa. But anyways, years ago, they came out with ground habanero powder. So I bought some. I took it home and I proceeded to do one of the dumbest things in my life. I said, I wonder how hot it is. So I took a little on my finger and went like that. And immediately I was in instant pain, not hot, pain. My tongue said, no. My lips and the inner part of my mouth, my gums said, no, you shouldn't have done that. You're going to be in pain. And I was. It was burning terribly. Now, there's something I'll teach you later on called like dissolves like. Things that are nonpolar, amides are nonpolar, are soluble in nonpolar things. Water is polar. So that's not going to take away the heat, which is caused by capsaicin, that amide. So what did I do? I know that vegetable oil is nonpolar. No, I didn't do shots of vegetable oil because I was standing right by my refrigerator, and mayonnaise is 50% vegetable oil. So I opened up the drawer where I had my silverware, grabbed the soup spoon, got the mayonnaise out of the refrigerator, and I'm in pain. I mean, I was at the point where I was thinking, do I need to go to the hospital, before all of a sudden I thought this one might do it. And went by my sink in the kitchen, took some mayonnaise, a big tablespoon, went like this, spit it out. No, I didn't swallow it. Did it once more, spit it out, and that helped get the capsaicin that was causing serious pain, not hot, pain in my mouth. And if you think about it, have you ever seen where they sell the buffalo wings with the super hot coating on it, which I'm not into? I like spicy, but not where it's painful. And they always serve it with a ranch dressing with celery and sometimes carrots. And why do they do that? Because the fat in this dressing, the dipping sauce they give you, ranch dressing or other things, blue cheese ranch. I don't like blue cheese. Other cheeses, yeah, but not blue. But anyways, that helps get the heat out of your mouth. Or if you've ever been someone eat hot peppers, and they'll say, oh, here, drink some milk. And in the milk, I'll teach you later on, one of the main ingredients in milk besides water is fat. Or another way people I've seen where they take bread and butter. Well, it's not the bread that gets it off, it's the butter, which is non-polar, the fat or oil. Anyway, so if you ever buy habanero, now they got ghost pepper powder. Wow, that's got to be even hotter than the habanero. When I cook with that, if I make a big pot of chili, I'll just go like think, think, think. That's enough. But the thing is, it gives it a little kick, but the taste from that is, oh, it's awesome. But you got to be real careful. Now, another thing, while I got the time, I do. Is, have you ever been to a supermarket and you have the bags where you pull one off to put your vegetables in? And nowadays, long ago they didn't, but nowadays they say, have Arrow open this in. And when you go to open it, oh no, it won't open. Well, what happens is plastic will stick together. It's called van der Waals forces. And it's hard to separate it. So let me see. I just happen to have a plastic bag here, and it's not one of those, but the same thing. Notice how easy this comes apart. That's because they put in there a chemical called an a slippery agent. And what it is this is a special amide where R is very long. R and the carbonyl is usually about 20 carbons or 22. And the ones were in the supermarket where you can't get open, you're just put it away and go to another row, because whoever made that either made a mistake or were cheap and didn't put enough amide in there. Didn't know that was organic chemistry. How do I know that? I worked for a company that made that amide, Axo, and it was part where I was in charge, and we had requests that I had to come up with a solution to make a much clearer amide to make sure this never yellows, and I did. Now, how do you make an amide? Good question. Now, I'm going to skip this slide, and I have a better way of doing it. And this slide I'm going to rewrite on the whiteboard. It's the same slide, but you'll see I've come up with a different way. I've decided, how do you make an amide? Start with a carboxylic acid plus either ammonia or amine. Remember, ammonia is NH3, and here R prime and R double prime can be hydrogen. And here when you react the two together, the hydroxyl group, use that plus this to make water. And remember, in amide, there are 3 bonds to nitrogen, which I have. And that's how you make an amide. Plus, you make water, but that's inorganic. Who cares about that? And that's how you make an amide. Now, let's look at a couple examples. And the question would be, what's the organic product or products are the following? And if we look at this, what is this? What's different? Carbonyl hydroxyl group, carboxylic acid. Here's my R group. What do we have? Ooh, a nitrogen. And it's an amine, which I can write like this. Where R prime and R double prime can be hydrogen atom. In this case, one of them is. I'll call this R prime, and one of these hydrogens R double prime. And what do you get? You get an amide. What's attached to the carbonyl carbon stays there, R. You have nitrogen, and on there you'll have your R prime and R double prime. Well, I have my R group, my carbonyl, and now nitrogen, and I have R prime methyl and my hydrogen. Now, one thing I should point out, there's another way of writing this, which I'll write over here. Either way is acceptable on a test. And that's just like with carbon, you put the hydrogen to the right and then CH3. And either one of these is acceptable on my test or in real life. And that's how you make an amide. Let me do one more. I just did methyl. And if we look at that, what do you see? We see, and I'll do this one, a carboxylic acid, carbonyl. Look for what's different, oxygen's there. But here I have ammonia. But remember, for this reaction, a carboxylic acid reacting with something with nitrogen in it, R prime and R double prime, one or both, can be hydrogen. And in this case, they are. And you'll get an amide. Remember, the nitrogen in an amide has 3 bonds to it, not 4. So here I can say that's R, and 2 of these hydrogens are R prime and R double prime. And therefore, I have my 2 carbons, because you don't break carbon-carbon single bonds to the carbonyl, nitrogen, and R prime and R double prime are hydrogen. Now I can write this another way. Sorry about the crowding here. Notice this nitrogen has 1, 2 hydrogens, so I can write it that way. And either one of those would be acceptable. So I better let you try some. And here's one for you to try. And as always, if you ever have any questions, ask, because there's no such thing as a dumb question in my class. Thank you, Joe. Thank you, Megan. And thank you, Tam. So I got you reversed. Thank you, Megan and Tam and Joe. All right, what do we have here? Ooh, a benzene ring, but that's not going to react with ammonia under these conditions. But I have a carboxylic acid. Here I have a nitrogen compound reacting with a carboxylic acid. That can be ammonia, which this is. And you see how I condensed those two slides, which I think this will be easier for you to remember instead of two separate reactions. And you get an amide. Now, our prime and our double prime are hydrogen. This is my R group. So I'll have this carbonyl, nitrogen, and it has two hydrogens. And you could have also written it this way. Don't forget to put the double bonds inside the benzene ring. And that's how you do it. Oh, let's do one more. These are fun. And here's one more for you to try. And remember, this is a way of writing two ethyl groups on that nitrogen. And by the way, everybody keep your fingers crossed, even though I don't think I have to worry about it. Tomorrow, I have an appointment to get my booster shot. I had to wait until 6 months after, which would have been about a week or so ago. But I wanted to wait a week or two after I got my flu shot too, which I got a couple weeks ago. But be sure to get vaccinated if you're not. Thank you, Megan. And Tam and Joe. So let's take a look at this. What do we have? Oh, a benzene ring, but that's not going to react with an amine. But here I have a carboxylic acid. And ooh, nitrogen. It's got not one, but two R groups. In this case, R prime and R double prime are both ethyl groups. But remember, for this general reaction, R prime and R double prime, one or both, or none, like we have here, can be hydrogen. And what do you get? You get an amide. In this case, my R group is this benzene ring with a methyl group. Notice it's 1,3, a meta. And therefore, I'll have my benzene ring Oh, that's the awful benzene ring I've ever written. Don't look. It's gone. That's better. Still has a methyl group, the carbonyl, then my nitrogen. And what's our prime and our double prime? Ethyl. But I could have also written it this way. And these two are the same. All right. Now, as I mentioned not too long ago, you should always be asking the question, why am I learning this stuff? And really, why are you? Well, you know the obvious, which I keep on telling you, which you know, because you're not going to become an organic chemist, but someone said you had to take this course to get in a program or into school so you can get in that school to get in a program like nursing or other things. Physician's assistant, dietitian. I've had all those major people in those majors in my Chem 170 class. But why learn this? Let's find out. This last summer, if you didn't want to get eaten up alive, so to speak, when you were mowing the lawn like I do in the morning, you put on an insect repellent. And the best insect repellent, the active ingredient, has the acronym D, and that stands for N-diethyl metathylamide, or sometimes it's called dimethylthylamide. And that's the structure over here. Now, this is the line method. End of the line is a methyl group, carbonyl. Bend of the line is a carbon, carbon here, carbon here. And this is the molecule you just made. And why are you learning this stuff? Because these reactions help make things in your daily life, like this one, insect repellent. And DEET, I think, is the best one out there. That's my personal opinion. I know some people say it's not good for you or whatever. No, I don't think so. Well, it hasn't killed me yet. I use a lot when I do my lawn. Now, interesting story. Do I have time? Oh, I do. When I first bought this house, first time I went out and mowed the lawn, I got eaten alive everywhere with mosquitoes and maybe other things too. They loved me. So I said, I better get an insect repellent. So I went to my local big box store, in this case, Walmart. I usually go in there only 4 or 5 times a year. It's too dangerous to go in there. Same thing with Costco. I try and limit it. Just go in there when I need stuff, get everything I need for a couple of months and get out of there. But anyways, so I went over to Walmart and I went to the area where they had the insect repellents and I had a brand name and it was, I looked at the label. Being an organic chemist, I know D is the key ingredient and it had about 2.4%. And it was a bottle this big. And then there was the Walmart brand. It was a bigger bottle by about 20%. And I looked at the label and the D was 4.4%. And it was cheaper too. Less expensive. That sounds more professional. And so which one did I buy? The Walmart. You get more and you get twice as much of the active ingredient that keeps mosquitoes away. And I've been buying it ever since for many, many years. It's still cheaper than the name brand. Off. But anyways, if you're in need next summer, you know where to go. And that's organic chemistry, helps make those things. What two chemicals would you react to make that product? And on test 3, like test 2, I have either 3 or 4 what I call synthesis problems. Now, these are easy ones. These are only one step. In real life, they can be many steps. I think the most I ever did for something we made in a chemical plant was, I think, 6 or 7 steps from what we bought to making the final product. That was fun. Thank you, Joe. Thank you, Megan. And thank you, Tim. Doesn't it feel good to be able to do organic chemistry and it's not that painful? All right, let's look at this. What's different? Ooh, carbonyl. Nitrogen. Notice this means there are 2 methyl groups, our prime and our double prime. And on the carbonyl carbon, I have carbons I'll call R. This is an amide. Remember, R prime and our double prime can, one or both or none, can be hydrogen. And how do you make an amide? You react the carboxylic acid with an amine or ammonia if R prime and R double prime are hydrogen. And therefore, if I look at this, I'll call this R, and each one of these R prime and R double prime. And therefore, my R group is methyl on my carboxylic acid, acetic acid, and my R prime and R double prime are methyls. I can write it this way, or you can write it this way. And that's how you do amides. Now, one of the things I'll be teaching you, and not to scare you, but everybody, touch your skin right here or on your hand. Did you touch it? Guess what? Your skin, the main key molecules in your skin, amino acids, are held together as amides. When you look at your skin, it's hard to do that and look at the camera at the same time. But anyways, these are amide bonds holding all the amino acids together. And I'll teach you that later on. So your skin is this one big amide polymer. Polymer means many repeating units. I'll teach you that later on this semester. All right, now once you have an amide, what can you do with it? Well, you can react it with acid and water. Now, I'm going to stick to the acid, hydrochloric acid. And I'll explain why in a little while. And if you react an amide with hydrochloric acid and water, you'll get back the carboxylic acid you would have used to make that amide, but you get the amine salt of the amine you would have used to make that amide. Why? Because remember, amines are bases in the presence of acid. You have an acid-base reaction. And you make the amine salt. And don't forget the anion. Now, it turns out this reaction is very important. You say that about all reactions. Oh, guess
Okay,
what?
Doctor.
I didn't show you it.
Yeah.
Oh, no. I've been pretty good this semester. I think that happens in Zoom. On a whiteboard, it never happens, but in Zoom it does. All right, let's look at acid hydrolysis. Instant replay. Let me rewind everything. No. All right, let's start again. All right, let's talk about reaction of an amide with hydrochloric acid, and water. And the acid we'll use is HCl, and I'll explain why in a little while. You get back the carboxylic acid you would have used to make that amide. Somebody should have yelled at me earlier, but I'm glad you did. I figured it out too. But anyways, and you get back not the amine, but the amine salt. Why? Because when you do this hydrolysis, you make the amine, but in the presence of acid, HCl, it means our acids, HCl, hydrochloric acid is an acid, you make the amine salt. So let's look at this again. Now, sometimes I'll put the HCl in water above and below the arrow, but for today, I'll write it like this. This could go over and above the arrow, like I've done with ester hydrolysis, and you get back the carboxylic acid you would have used to make that amide, plus the amine salt. And you don't have to put charges, I will. And don't forget about the chloride anion. And this is a awful looking H, sorry. Now, why is this important? Because I'll teach you later in the semester, this reaction with amides and HCl and water. Well, first of all, let me ask you a real important question. Right now, where you're sitting right now, where would you find acid and water? Real quick. Anybody?
Your stomach.
That's it. Very good. In your stomach. And the reason this reaction is important is this is the way your stomach, and I think it's your small intestine, but don't quote me on that, break down protein. If you had anything with protein in it, if you eat hot dog, steaks, or chicken, that's how it breaks down. If you're a vegan and you had something like soybeans or other things with proteins in it, when you chew your food and swallow it, it goes in your stomach where the acid and water breaks it down. And I'll teach you later, it breaks down to your amino acids that your body then uses. If we look at this, what do we have? We have what's different. Ooh, carbonyl with a nitrogen, with stuff on nitrogen, stuff on the carbonyl. We have an amide. And remember, R prime and R double prime can be hydrogen. And if we react to it in here, I'll write it above and below the water, the arrow. I'm thinking ahead. This is the same as that. And what you get back is the carboxylic acid plus not the amine, but the amine salt of the amine, because in the presence of acid, the amine salt is protonated. That means becomes the amine is protonated. That means becomes the amine salt. And we'll use chlorine. Now you could chloride as the anion. They could use other acids, but most of you, I think all of you are in some way health-related majors. So let's take a look at this. Here's my R group. I'll call this R prime. Doesn't matter which of these you call R prime and R double prime. So my R group will be here. And my R prime, I can say is hydrogen. R double prime is not R. Oh no, I've got R in the brain, is ethyl. And then I'll add 2 more hydrogens. And I'll have, let me move us over here. I have my chloride anion. Now this you could have written like this. Notice that nitrogen has 3 hydrogens. And either one would be correct. And that's acid hydrolysis of an amide. So I better give you one to try. And there's one for you to try. Thank you, Megan. Thank you, Tam. And Joe's done too. So let's take a look at this. What's different? Ooh, oxygen double bond to carbon and nitrogen to that same carbon. And on the nitrogen, we have carbons, which I'll call R prime and R double prime. On the carbonyl carbon, we have carbons. And this is an amide. And here we have R prime and R double prime can be, but in this example, they're not. One or both or none can be hydrogen atom. And when you react it with acid and water, you get acid hydrolysis of an amide. To make a carboxylic acid, you would have used to make that amide plus the amine salt of the amine. You would have used to make that, because remember, amines immediately react with HCl to make the amine salt. So here, this is R, and in this case, R prime and R double prime are methyls. So my carboxylic acid will be this. oops, made a mistake, will be this. And my amine salt, I can write like this. Or like this. Notice there are two hydrogens on there too, so I can condense it like this. There are other ways you could write it that would be correct. And that's how you do it. Now, if I look at the clock, I've been working hard today because it's a lab day. So we'll pick up on this on Monday, and it's time for a lab. And today's lab is carboxylic acids and carboxylate anions. It's going to be a fun lab. I'm going to get into something you never thought you'd learn about in my class. There are a lot of times that's going to happen and still left to go. So let's look at today's lab. But first, let me close a few things. Hold on one sec, maybe 2 seconds. All right, everybody see carboxylic acids lab on your? All right, today we're going to talk about carboxylic acids. And carboxylate anions. All right, and in the first one, we're going to look at one of the things when I wrote these labs, and sad we can't have it really do it in face-to-face, but you'll still get the same mental exercise, and that is, are these soluble in water? And here you take some test tubes, fill them up about halfway with deionized water, and each test tube you put a couple of drops of the carboxylic acid, or if it's a solid, a small amount of solid, you shake it up. No, you don't shake it up that way. Where's this will be my test tube. You never shake it up this way. Either go 1, 2, 3, 4, or you put it on the vibro mixer, which we use in our lab. And you look and see, is it a homogeneous, it's soluble? If there are 2 layers, it's insoluble. Now, one of the things I don't have here, but will help you, is underneath the name, actually, I shouldn't say right. Draw the structures. Now, we have acetic acid, propanoic acid, stearic acid, and oleic acid. Ooh, what are those? Well, use Google and you can find out, but I'll tell you their R is very long in stearic and oleic. And if you notice, I've already given you the results. We've done this enough times, I've watched it, and I also set it up, that the first 2 are soluble and the last 2 are not. And that's the first experiment. Now, next one is a lot of fun because you get to work with, if you were in the lab, some very dangerous hazardous chemicals like acetic acid, which is really, I have put out a bottle of vinegar, lemon juice. Ooh, this next one is real dangerous. Tomato paste, then stearic and oleic acid. And what you do is you take and dissolve some in water, and using pH paper. I think, has everybody here used pH paper? Have you used that? Give me a thumbs up if you use pH paper at one time. All right, pH paper changes color, different pH. Remember, pH is the hydrogen ion concentration, it goes from 0 to 14. Below 7, something is acidic. Above 7 is basic. And for this, the general reaction, which I taught you already, whoops, extra plus, is you get a carboxylate anion, carbon dioxide, and water. Now, what this really does is neutralize the carboxylic acid. And remember, I told you about my father's recipe with spaghetti sauce. And if I'm really telling you the truth, if you add baking powder, sodium bicarbonate, to a carboxylic acid, the pH should increase, go from acidic to basic. In today's lab, you would have found out, am I lying to you or not about this? That's the nice thing about organic chemistry or science in general. You go in the lab and you prove things. Now, these all lemon juice and tomato paste have citric acid in there, carboxylic acid, and stearic acid and oleic are carboxylic acids. And here I give you the results. And also, what do you observe? You would see bubbles form. In case you're interested, look at the following YouTubes to see that. You should. They're a lot of fun to watch. Now, the last part, yep, that's the last part. We're going to be doing 2 reactions. And that's the reactions of stearic. Actually, it says stearic up here, but we're only going to do acetic and oleic. Now, you're going to have an Erlenmeyer flask, and that's a flask that allows you to stir things by just using wrist action with your hand, and you'll put in some of the carboxylic acid and some phenolphthalein indicator. Phenolphthalein indicator, when the solution is acidic, it's clear. When it becomes basic, 1 drop, 1 molecule above pH 7.0, it turns what I like to say a wine color. It's really fun. And you'll be adding first sodium hydroxide dropwise until you see a color change and you observe what it looks like. And then you'll add some magnesium sulfate and you'll observe what it looks like. And let's take a look at this video. This one let's look at. Hang in there, we'll be done in about 5-6 minutes. So just hang in there. I know we usually take a break, but this is going to be one of those times where I want to finish.
Friends would walk up to me and just be like,
sorry about the commercial. Oh.
And here today just to show you the different Jason Angle with Tri-County Water Conditioning out of Hutchinson and Prior Lake. And here today just to show you the difference that hard water and soft water have on your detergents and cleaning supplies you're using. So what we're going to do here today is just add 3 drops of just pure soap solution, so it doesn't have all the additives that you'd see at a retail store. So we're going to add 3 drops to the hard water beaker here.
Everybody see the YouTube?
And then we're
Thank
going
you.
to add 3 drops to the soft water beaker here. And what I'm going to do is just mimic basically a washing machine, and we're going to shake these 2 up. Hard water first, You can hear the 18 grains hardness we have in Prior Lake water. So not much effect on the 3 drops of soap solution we added here. Here's the soft water. Much different sound, not nearly as loud. You can see all the suds that we're getting for that one. And if we even add another 6 drops to the hard water, we'll just see if we get any more effect. Just kind of showing you the savings you're going to get having soft water as opposed to hard water, because your soap solutions are basically fighting the hard water, and you're not getting any results from that.
Watch the Erlenmeyer.
So we get a little
If
bit
you
here,
look
but
on the
slowly
side there,
dissipates
there's
down.
a
We're now-
solid
we kind of
forming.
zoom in a little bit. On the hard water, you can actually see your soap scum build up. on the side
Soap
of that
scum,
beaker.
solid.
So that's where you're seeing the buildup in your shower, shower doors, shower curtains, and also that detergent isn't able to release from your clothing, bedding, things like that. Where now, if we look at the soft water, you can see in the beginning how clear it is at the bottom
You see how clear it is? The soft,
then
there's
nothing's
no
sticking
solid in there.
to the side of the beaker.
All right, let's
This water-
explain what that's all about. Now, in this reaction, does everybody see my whiteboard now? You're going to be doing this carboxylic acid, 2 of them, where R is different. And first, you're going to react it with sodium hydroxide, acid base, and don't forget you're in water. And this is DI water, which means there's no ions. Soft means you have less than 50 ppm, and hard you have more than 150 ppm of ions, mainly calcium in our water in Chicagoland. And first, you'll make this carboxylate anion. And we'll learn later on for bar soap and certain detergents, but mainly bar soap, that's the structure when R is long. Now you're going to do one where R is short and where R is long. Now the second reaction, you're going to take this, which I'll do here, and the same Erlenmeyer, you'll add some magnesium sulfate. Instead of using calcium sulfate, this is just easier to work with. Now, magnesium sulfate is really this. Mg plus 2 SO4 sulfate minus 2. It's an ionic compound. And what you have is called ionic exchange. I'm going to do something very rare for an organic chemist. I'm going to balance this reaction. And when you mix the 2 together, what you'll get is ion exchange. This is soluble in water. Now, depending on R, that will affect the solubility of that new, this is called also a carboxylate salt. And one of the things you've already learned this semester is the greater the molecular weight, the more carbons a molecule has, the less soluble it is. And you're going to find out, is there a difference between this molecule, water solubility, and this molecule, water solubility? I didn't spell solubility right, let me know. I tell you, I was always first down in spelling bee, and to this day, spelling is not, certain words are not my specialty. And that's what you're gonna do. Now, I'm gonna give it away. When R is large, which is oleic acid, oh, white solid is formed. And oleic acid, or the carboxylate anion of that, is found in your bar soap. And if we were in lab right now, and you would be swirling it, and you see that white solid much stronger than what you saw on the YouTube, I'd be coming around and asking you, do you know what you just made in your Erlenmeyer with the oleic acid? And all the students will say, I don't know. They may not make the face I just did. I don't. I'll say, you just made soap scum. And yes, that's organic chemistry. Now, I'm going to wait until we get into fats and oils, but how many of you hate cleaning bathtubs with a lot of soap scum in it? Give me a thumbs up. I'll give my 2. Well, I used to, and finally it dawned on me, Dr. White, you're an organic chemist. Instead of spending a half hour, because I usually let my bathtub go too long before I clean it out, so there's a lot of soap scum in it, on the wall too. You're an organic chemist. How could you clean it much easier, much quicker? Then it dawned on me, oh, you should have done this years ago. And I finally said, yeah, I should have. And I'll teach you later on, use a product called Barkeeper's Friend. And when we get into fats and oils in a couple of weeks, I'll teach you how that you can do a bathtub that's got tons of soap scum on it. I mean, really cake bad, really funky looking. In about 10 minutes, your actual, less than that, scrubbing and washing down the sides time. And about 20 minutes, you give it some time to just sit and react. And it's real easy. And I've had students do that and they love it. So that's coming attraction. And with that, for the lab, don't forget to answer the questions at the end. This is due next week. And with that, I'm going to say, gang gesund. I'll see you on Monday. On Monday, I'll have 2 very important announcements to make. So make sure you show up, please. And with that, I'll say have a nice rest of the week. And weekend, I'll see you on Monday, unless you have questions, so you can come to my office hour night. With that, gang gesund. Goodbye.